So now we're going to talk about the last measure of central tendency, which is called the mode. And you may have heard about the mode before in your previous stats class. The mode is probably the least common measure of central tendency, and it's also probably the, maybe some people might argue with me, but I think it's probably the least useful in some ways. But the mode is essentially just the category of a variable that contains more cases than either of the adjacent categories. Okay, so it is probably often referred to as the most common value reflected in a set of scores. Okay, so here I have the possible number of cups of coffee, the number of people who had that many cups of coffee, and that again is just reflected here in our data is 876,543, and the number of people is F2112332. So the mode is really just some people would want to refer to as the mode as 3, because 3 is the most common. Right here you see frequency, so the most number of people who've had the most number of people of any given category is 3. So some people might refer to this as the one single mode, but it's actually technically 2 modes, because this 2 over here is greater than the 1 next to it. So it's sort of a bimodal distribution. So 2 is greater than the 1 below it is not greater than 1 or 2, so it's not a mode. This 1 is not, this 2 is not greater than the 3, or it's only greater than the 1, so it's not greater than on both numbers either side of it. And this 2 is not greater than the 3. So this 2 is greater than the 1, and this 3 is greater than both the 2 and the 2. So for that purpose, there's 2 modes. There are 2 modes in this particular table. It's also not influenced by extreme bias, just like the median is. But as your sample size increases, these modes will change or disappear and so on. So likely this 2 would go away, and this 3 might get stronger. Who knows? It's hard to say with only this number of people. A mode is also better. It's often seen rather than in a graph rather than seen in a table. So let's talk a little about skewness, and this is how it ties into modes and medians and means. Here's a table of data that are just graphed. Say this is age, and if you graph it like this, and it's a perfect little. You see the graph here? It's this perfect little bell-shaped curve. The mean and the median and the mode all fall in line in the same exact spot down the middle. The mean is right here. This is the mean age, and the mode age would be right here, and so would the median. So this is called a unimodal symmetric frequency distribution. So it's called unimodal because it's one mode. Unimodal meaning uni meaning one, and mode meaning modal meaning mode. So there's only one mode here, right? So there's only one mode, and it's symmetric because on either side of this line, they're exactly the same image. In fact, you could fold this side over on this side, and they would be 1 for 1. So fold this over here, and that side would be exactly the same size. And in that case, we have a unimodal symmetric frequency distribution. Here's another example of data distributed differently, though. This is actually called bimodal symmetric distribution because it has 2 modes. So again, unimodal means one mode, bimodal means 2. So we have one mode here, and we have one mode here. So modes are represented by the peaks of your data distribution. So again, here we only have one peak, right? One peak. It doesn't go anywhere else. It just peaks out one spot. Here, it peaks in 2 spots. There's one mode there, and there's another mode there. So in that case, it's bimodal, and it's symmetric still, because if this is the middle, right, the middle of your data, and if you fold this over here like that, that peak would fall right on top of the other peak. So in that case, this is a symmetrical bimodal frequency distribution. And the modes occur roughly around 2 and just around, not 6 exactly, probably around 5.5, 5 3/4, something like that. And in this case, the mean and the mode occur right in the middle. So the mean and the median occur right in the middle between the 2 modes. in this particular bimodal symmetrical frequency distribution. And here's another graph of skewed data. This is called a unimodal asymmetrical frequency distribution. Again, it's unimodal because it only has one mode, right? It's one peak in the data, one peaks right here. It's asymmetrical because you can't fold this side over into the other because it's not a mirror image of either side, right? And it's skewed to the left. We call it skewed to the left if the data aren't represented mostly to the left. It's actually represented mostly to the right. So it's skewed to the left, or it's also sometimes referred to as a negative skew. So if the data are sort of pushed to the right, it seems like all the data are pushed over here to the right, that means it's skewed to the left. Okay, it seems a little bit backwards, but that's the way it's described, and it's negatively skewed. And in this case, the mean, median, and mode are all spread out. So the mean of the data would actually be right around here, the median would follow right around here, and the mode, as you know, is the highest peak in the data. So the biggest peak in the mode right here is found right here. And here we have a unimodal asymmetrical frequency distribution when it's actually skewed to the right, or sometimes called a positive skew. Again, we have one mode, it's unimodal, and it's all the data are peak at one spot. They peak right here, so it's one mode, and the median falls right here, and the mean falls right here. It's asymmetrical because it's not a mirror image. The sides are not a mirror image of one or the other. So you can't fold this side over onto this side and have it be exactly the same. And it's skewed to the right because it's almost like the data were all pushed from the left to the, from the right to the left. So in that case, it's skewed to the right. It's positively skewed. And last but not least, this is the bimodal asymmetric frequency distribution, which is skewed to the right, which is a positive skew. Again, let's talk it through. We've got data that are distributed bimodally. We have one mode here and one mode here. So two peaks, right? Two peaks in the data, one peak and another peak. So we have two modes. Two modes equal bimodal. It's asymmetrical because you can't fold this piece over on top of this piece and have it be the same. In fact, this peak is higher than this. So it's not bimodal, it's not symmetrical, it's asymmetrical. And it's skewed to the right because it looks like the data were actually pushed slightly to the, or it's positively skewed. It looks like it's pushed all the way over here to the left. So the data were actually pushed from right to left, and so it's skewed to the right, or a positive skew.